particular problem, is that I find the possible values of theta in the equation 2 cos square theta equals 1 plus sine theta. Okay, where 0 degrees less than or equals to theta less than or equals to 360 degrees. Let's look at how to deal with this particular problem. So here we have our equation to be 2 cos square theta equals 1 plus sine theta. Now, here you can see that the ratios over here are different. Here is cos, here is sine. In a situation like this, you won't be able to solve it. You can't solve it in this manner. Do you get it? So what you have to do is, you have to find a way of converting one of the ratios to the other. Okay, you convert it from one of them to the other, either from cos to sine or sine to cos. Anyway, where it is possible, right? So here over here, you can see that for sine theta, there's something we can do. We can convert sine theta to cos theta over here. So the best thing for me to do is to convert cos square theta to sine theta, because we know from our first identity, right, that cos square theta plus sine square theta equals 1. So if we make cos square theta from that identity, we are going to have cos square theta to be equals to 1 minus sine square theta. Okay, so in place of cos square theta over here, we can put our 1 minus sine square theta. I hope this one is clear. Okay, so over here, let's convert this one. So cos square theta, from our first identity, we know that equals 1 minus sine square theta, right? Okay, and this one should be equal to 1 plus sine theta. So in so doing, you will realize that our ratios will now be the same, so that will be easy for us to solve. Okay, so let's expand this bracket. So we are going to have 2 times 1, we have 2 minus 2 sine square theta, and this one equals 1 plus sine theta. So this side you can see that the square over here is negative. Okay, so let's send everything over here to the other side of the equation, so that we'll be having them to be positive. So we are going to have 2 sine square theta. Okay, then we have this one is already there, so we are going to have plus sine theta. Okay, then we have this one already there, plus 1. This 2 is boiling, so you count minus 2, and everything becomes everything will be equal to 0 over there. So this is what we have. We can simplify this one further by having our 2 sine square theta plus sine theta, and this one will give us minus 1 equals 0. So you can see we are getting a quadratic equation over here. Okay, quadratic equation. So we can let our sine theta to be any variable for our choice. Sine theta to be equal to, let's say, p. Okay, let sine theta to be equal to p. So wherever you see sine theta, we put our p over there. So in this case, we are going to have 2p squared, okay, plus p minus 1 equals 0. So we will have to solve this quadratic equation. Okay, we have to solve this quadratic equation. So let's use factorization at this point. So here we multiply the coefficient of p squared by the constant. So 2 times minus 1 is going to give us minus 2. And we need 2 factors. When you multiply, you should get minus 2. When you add, you should get positive 1. Can you see that for factorization? So here I think positive 2 and negative 1 will do, right? Positive 2 and negative 1, because negative 1 times 2 is going to give us negative 2, and negative 1 plus 2 is going to give us positive 1. So here, let's put the factors at the middle. So we have 2p squared plus 2p minus p, okay, minus 1 equals 0. That's what we have. So we can put that in bracket nicely. Okay, so over here, we can see that there's 2 here, and there's also 2 here. Okay, for factorization, this 2, there's 2 here, 2 here, so 2 can come out. Then we have 2 of the p's. So p squared means we have 2 p's over here. Here too we have 1. So we can take 1 p out. Okay, so in this case, we are going to have, this one's going to have, we are going to have 2p out, 2p out, and so when the 2p is out, we will be left with 1p over here, and here we'll be left with 1. Okay, you can see that. Good. So we are going to have p plus 1 over here. Okay. Then at this point, let's look at the next one. So we have minus p over here, minus 1 here. So here you can see p is here, there's no p here, right? But there's minus 1 over here. Okay, just that we don't write it. So every number has 1 attached to it. So this p, there's 1 before it over here. So we can bring the minus 1 out. Because minus 1 is here, minus 1 is here. So we can factor minus 1 out. So we are going to have minus 1, open bracket, p plus 1. Okay? Because, so when the minus 1 comes out, it means this sign over here becomes positive. So that is why we are having positive over there. Okay? So that's what we have. And therefore we can take one of items in the bracket, p plus 1. Then those at the back we can put them in one bracket. So we have this one to be equals to 0. So we can have 2p minus 1 equals 0. So it's either this one is equal to 0 or this section is equal to 0. So if this one is equal to 0, we are going to have p to be equals to minus 1. Okay? Then if this section is equal to 0, p will be equals to 1 on 2. I hope you can see that. So here we know that p is not on its own. It is representing something. We know that p is representing sine theta. So we can do the substitution over there by putting our sine theta at its rightful place, plus negative 1, or sine theta equals half. Okay. So now what we do over here is that sine theta equals negative 1. But take note, this negative sign over here is only telling us or showing us the quadrant in which theta is falling. Okay? The negative sign is telling us or showing us the quadrant in which theta is falling. So we know that sine to be negative, we know that sine is negative in the third and fourth quadrant. Okay, we know that sine is negative in the fourth and third quadrant. So what we do is we find the sine inverse of 1. Sine inverse of 1. I know that sine inverse of 1 equals 90 degrees, right? Now this 90 is not part of the solution, because this 90 is talking about the first quadrant, because here we are using the positive value of 1, not the negative. That's why we are getting 90. So let's find the actual solution. In the third quadrant, we know that to find theta in the third quadrant, we use theta minus 180 degrees. So theta minus 180 degrees equals this 90. I hope you can see that. Good. So in this case, we make theta the subject, and theta equals to 270 degrees. So there's one solution for theta. Okay. And we also know that Sine is, so this one is for the third quadrant. Take note, the third quadrant. So in the fourth quadrant, sine is also negative. So what do we do? In the fourth quadrant, we know this, we use the expression 360 degrees minus what? Theta. And this should be equal to this our 90 that we have found. So in this case, we are getting a repeating answer, right? A repeating value, which is the same as 270 degrees, right? The same as 270. So this is for the first part of our solution. Let's look at the second part over here. We apply the same principle. Sin theta is equal to half. And we realize that half is positive, right? And which of the quadrants do we have sine to be positive? Which is the first and second quadrant. So in the first quadrant, you can find sine inverse of half. And what is our sine inverse of half? Sine inverse of half is going to be 30 degrees, right? 30 degrees. Now, this one is part of the solution because sine is positive. So this finding sine inverse of half being 30 is part of the solution because the 30 is in the first quadrant. Now let's find the corresponding value in the second quadrant because we know that sine is positive in the first and second quadrant. And this 30 is representing the first quadrant. So let's find the corresponding value for the second quadrant. So over here we are going to have, in the second quadrant we know that 180 degrees minus theta is the expression to find our theta. And this one should be equal to our 30 that we have found here. And this one should give us what? Making theta the subject, we know that theta is equal to 150 degrees. So therefore, our value for our solution for theta is going to be 30 degrees, 150 degrees, and 270 degrees. So this will become the solution for our theta. So from the first part, we know that theta is equal to 270 degrees from the third quadrant. This is for the third quadrant because of the negative sign over here. And the negative sign is showing us which quadrant is theta falling. So we know that sine is negative in the third and fourth quadrant. So that is why we are using this expression representing the third quadrant. Then we equate it to 90. That is sine inverse of 1, 90. And we are having 270 degrees. But here we are having repeating solution. So we take one of them, which is 270. And then we do same for the other part. Another part, we realize that the first quadrant we are getting 30 degrees. Then in the second quadrant, using the expression over here, we are getting 150 degrees for the second solution. So in all, theta is equal to 30 degrees, 150 degrees, and 270 degrees. Good.